Theorem 2. Log m by n to the base a is equals to log m to the base a minus log n to the base a for m positive and n positive values. So, where a is also positive and a not equals to 1. And we shall prove this one by assuming that log m to the base a as x and log n to the base a as y by converting logarithms to the exponentials, and then we shall try to prove this. Log m to the base a is equals to x, and that implies m is equals to a to the power of x by the basic definition of logarithm. Log m to base a is x, then m is equals to a to the power of x. Similarly, log n to the base a is equals to y, which implies n is equals to a to the power of y. And if you take up the ratio m by n is equals to a power x by a power y, and that implies m by n is equals to a power x by a power y simplified as a power x minus y. So, a power m by a power n equals to a power m minus n. So, m by n is equals to a power x minus y. Now, let us go back to logarithm definition. If m by n is a power x minus y, logarithm of m by n to the base a is equals to x minus y, where x equals to log m to the base a, where x is log m to base a minus y is log n to the base a, log n to the base a. Overall, log m by n to the base a is equals to log m to base a minus log n to the base a.